The last thing we have to do with proof by induction is to do with powers of matrices and formula for the nth power of a particular matrix. It's probably the easiest of all the different things that we have had to do in the induction chapter. So let's take a nice simple example. We have a matrix M, 2 minus 1, 0, 1, and we have to prove that m to the power n is 2 to the n, 1 minus 2 to the n, 0, 1, and I really should have said for all positive integers n. That means that we start at n equals 1. So when n is 1, m we know is 2 minus 1, 0, 1. That is m to the power 1. And from the formula, we get m to the 1 is 2 to the 1, 1 minus 2 to the 1, 0, 1. 2 to the 1 is 2. 1 minus 2 is minus 1. And we have 0, 1. So that is what we ought to get. And we conclude that the formula is true when n equals 1. Okay, we all know what to do now. We assume that we can find some number k, so that m to the k is equal to 2 to the k, 1 minus 2 to the k, 0, 1. Really quite simple. Let's look at k plus 1. M to the k plus 1, well, it would be if it looked like a k, that's better, is m to the k times m. Well, our induction assumption tells us that we're assuming that m to the k is 2 to the k, 1 minus 2 to the k, 0, 1. M is 2 minus 1, 0, 1. And we now just have to make that look as it should be. Well, this is equal to multiplying the top row by the first column, 2 to the k plus 1 plus 0. Rather like that. So we get 2 to the k plus 1. What do we get into the next column? We get minus 2 to the k plus 1 minus 2 to the k. Well, let's just write that out. Minus 2 to the k plus 1 minus 2 to the k. And then in the next bit, we get 0, 1 times 2, 0 is 0. And in the last bit, we get 0, 1 times minus 1, 1 is just 1. It doesn't take much to sort this out. We have 2 to the k plus 1, which is what we want. We have 1 minus 2 times 2 to the k, 0, 1. And that, without too much difficulty, is 2 to the k plus 1, 1 minus 2 to the k plus 1, 0, 1, which is exactly what we would get if we put k plus 1 instead of n. So now we can conclude that the formula, can't spell, that the formula is true when n equals k plus 1. And now we just need the last paragraph. We have shown that the formula is true when n is 1, and that if the formula is true when n is k, then it's also true when n is k plus 1. Therefore, m to the power n is 2 to the n, 1 minus 2 to the n, 0, 1 for all positive integers n by induction. This you can find, and one or two more examples, in your textbook FP1 on pages 133 to 134.